This is part 2 for introduction of digital signal processing. So we're going to talk about some basic ideas for signal processing in digital way. Okay. So like we mentioned in the first part, we know DSP is everywhere. Okay, so we're going to show some examples, right? How can we use digital signal processing in our daily life in any other areas? For example, we can use DSP to do sound, acoustic signal, audio signal application, like sound, speech comparison, enhancement, special effects, speech synthesis, speech recognition, and echo cancellation. So you can find this kind of component or processing procedure in cell phone, right? In MP3 players, movie, right? Text to speech. In communication area, we can also use signal processing. For example, DSP can be used to do modulation, coding, decoding, detection, equalization, echo cancellation. So you can find DSP in cell phone, right? In modem, in satellite receiver, right? In base stations, in routers. Automobile, right? Automotive, we can find DSP doing jobs for, right? ABS, right? GPS navigation, active noise cancellation, right? Cruise control, self-parking, right? auto drive, right? In medical application, DSP plays really important role for processing biomedical signals. For example, right, MRI, right, tomography, electro, cardiology, and EMG, EKG, right, many of them. Military application, DSP widely used in radar signal processing, sonar signal processing, space photograph, and remote sensing. So in terms of image and video application, right now, right, almost all the images and videos, right, most of them, they are recorded, right, transmitted, stored, displayed in digital way. So we can, for example, DVD, right, JPEG, MPEG, special effects, right, video conference. We use DSP to do all those kind of jobs. And in mechanical engineering, people also use DSP a lot to process and control. So signal processing, right now, human beings still are considered the most advanced signal processors. For example, we are doing speech and pattern recognition, right, every day, and we also do speech synthesis. We also do, like image processing, right, image recognition, signal detection, right, in our daily life by using our, brains. Our brains. However, right, now, artificial intelligence are doing work better and better, and in my mind, it will be outperform human being, right, pretty soon. So as human being, we encounter many types of signals, right, in different applications. And how can we process those signals in electrical engineering by DSP, right? We have to change them into generally voltage, current, or magnetic electrical field signals. Then we can process them, play with them. Some signals we deal with in our daily life, for example, mechanical signals like speed, right, force, displacement, need to be changed into electrical signals by different sensors. And acoustic signals, audio signals, we're dealing with like sound, right, vibration, need to be changed into digital signals by microphone or transducer. other signals like pressure, temperature, right, also need to be changed into electrical signals by different sensors. Okay, so in your discussion board, right, I want to discuss signal processing. So just think about the devices, right, systems you have used in your life. I want you to think about the best and the worst, right, signal processing device or system, right, in your experience, and why you like it and why you don't like it. Another thing I want you think about and name the most important three things for a signal processing system or device. Right? Please think, if you are an engineer, right, you're going to design a system doing signal processing jobs, and what will be the most important three, right, in your mind, and why. Okay, so now we talk about a little more details about signal processing and why, right, we talk about digital signal processing. As we know, most of the signals in our real life, when we encounter a signal, most of them, not all of them, but most of them, they are continuous. They are analog signals, continuous in time and amplitude. So we have to convert them into electrical signals, right? Then we can use electrical circuits or DSP to process them. So if we have analog signals, right, directly from sensors, we can use analog circuits, right, to process those signals. For example, the circuit may including resistors, capacitors, inductors, amplifiers. So analog signal use analog circuits to process, right? It's straightforward. For example, we can find analog circuits, right, in radios, right, in FM radio, AM radio, and traditional TV sets, right. Now in the States, right, you cannot find the traditional TV set, but in some developing countries, right, there are still some TV sets like that. So even using analog circuits to process analog signal is, the original format, right, of the signals we are dealing with in our daily life is straightforward. However, right, there are some limitations. So some not very good things, right, for analog circuits. So here are some of them. The first one, accuracy limitation, is due to component tolerance and undesired non-linearity. So generally, right, depending on the component, for example, resistors, right, inductors, capacitors you use in a circuit. So for each electric component, right, it may have its own, right, tolerance or range. So accuracy is highly related with the quality, right, or the dynamic range of your component, also the circuit itself. Second, repeatability is limited. So you can find one circuit design for this system cannot be used directly, right, for another system. So repeatability, right, use the same circuit, right, in different application is really, really hard and even, right, impossible. Besides that, right, changing the environment conditions may also make your circuit, right, work weirdly. For example, right, for some extreme condition, right, for example, in North Pole, South Pole, right, the circuits required over there will be way more expensive, right, because the temperature, right, extremely cold, right. So electrical analog circuit, right, may have different limitations based on environment. Okay, some other things. Sensitivity to electrical noise. This is analog circuits. And inflexibility to change, like we mentioned, it's really hard to, once you have a circuit, right, it's really hard to change, right, the purpose of it or change performance of it. So you may have to change entire circuit, not only change one or two components. Even change a component from a circuit is hard. Next limitation, limited dynamic range for voltage and current. So once a circuit is designed and built, right, dynamic generally is determined. And for some very special, right, operations like nonlinear operation or time-varying operations, really hard to implement analog circuits. And the last limitation we consider is storing information, or store signal is really hard or really expensive. So based on those limitations, people use digital signal processing. Okay, digital signal processing, we have three blocks. So this is the most important part. We call it digital signal processor. So this is the processor. The input digital, right? Output is also digit. However, as the signal in our real life, they're analog. So before it, we have a AD converter, right? Added. And after that, we need to change those digital signal, right? 1001 bit stream back into analog signals. So in this case, if you have an image, right, we change it to digital, right, process it, okay, make it back into an image. So this is the three blocks in digital signal processing. This is the main part doing the work you want. For example, comparison, right, transformation, or filtering. Before, after it, we have to use AD and DA converter. Okay, so this is the most general case. There are also some special case. You may only need one part, right, or two parts from the three. So here, the most general case is the first one, analog in, analog out. So we have all three together. Okay, second case, we still have analog signal in, but digital output, so we do not need to change it back into analog anymore. So for example, right, you have analog input, but digital output, touch tone, right, phone dialing, and you have some analog input, right, but you just need to send it through internet, right, digital output. And sometimes, right, not very popular, we have digital input but analog output. For example, right, text to speech, right, speech synthesis. And sometimes we have only digital input and digital output, no need for AD/DA converter. So for example, you have digital file, right, input and compress it, right, or interleaving it, right, and you send it out. For example, compressing a file, right, on computer. So for digital signal processing, right, the motivation using it because of the limitation for analog, right, signal processing. So advantages for digital, actually, those things just overcome the shortcomings we discussed for analog. For example, accuracy can be controlled by choosing word length. So accuracy can be controlled, right? If you choose longer word length, right, it will be more accurate. So when you learn your programming language class, right, you know you choose integer, right? You choose word, you choose floating point, right? You have different accuracy. Okay, second advantage, well, good thing, repeatable. It's repeatable. So a DSP system can be used here and also there, right? And also there. So because you have a digital signal processor, right? It's like computer. Once you have this program, you can use it here and there. Just, you know, a different processor, but same program. Okay, sensitivity to electrical noise is minimal compared to analog, because for digital, we only need to know it's 1 or 0, right? Positive or negative. So electrical noise is minimal. Later we show examples for that. Next advantage is dynamic range can be controlled by using floating point numbers. So it's similar, right, to accuracy. Next, flexibility can be achieved with software implementation. So this one actually is also, right, similar to repeatable. Flexibility means you have, you know, a device, right? So this time you want it to do comparison, right? Next time you want it to do coding, decoding. So you only need to change is the programs, right? The code for your processor. Also, like you have a computer, right? You can use it, you know, edit your video, right? You can also use it to play video game. So flexibility can be achieved by using different apps, right? Different software implementation. And compared with analog, nonlinear time-varying operations are way more easier to implement. It's easier to implement compared with analog, but still, right? It's not really easy to implement compared with linear, right? Operations. Okay, next, digital storage is cheap, right? We know compared with analog ones, right? It's cheap, and the capacity, right, is larger and larger. Okay, next, digital information can be encrypted for security, much easier compared with analog. Price performance and reduce time to market. So we know, right, same performance, price reduce a lot, right? Same price, performance increase dramatically. However, there are also some disadvantages for digital signal processing. So like everything, right, has two sides. Disadvantages I want to mention here. First, when you do AD converter, right, we have to sample the signals. So sampling may cause loose information. We're going to talk about that in our following lectures. So when we talk about sampling, we know we're going to talk about why we're going to lose information and how can we, what can we do, right, in order to not lose information or try to lose less amount of information. Okay, second limitation, AD and DA converters require mixed signal processing hardwares. So it's pretty tricky there. And if you have high speed, really high speed AD-DA converter, it's really complicated. Limited speed of processors, right? So processor calculation speed is a bottleneck for many of the applications. The limitation, quantization and runoff errors is something there, right? So sampling, you can do something to make no information loose, but quantization errors is there, always there, no matter how good, right, is your AD converter. There are still some run-up errors during the processing. Okay, so that's all.